Welcome to the new video on the basics of Python. And in this video, we are going to discuss lists. Now, list is the first array data structure that we are going to encounter in Python. So what we have seen so far are primitive data types. Integer is a primitive data type, so is a float, string, all of that, right? But there will come a need where you'll need to store multiple data types inside a single data type. So for example, if you have a bunch of numbers that you want to store, let's say age, right? You have 5 people, you want to store 5 people's ages. Then what do? You will have to invoke the use of a list. Okay. So lists in Python represent ordered sequences of values. So here is an example of how to create them. You basically create a list by using square brackets and then a comma separated list of what all values you want that list to hold. And then of course, lists, like everything else, is just treated like a variable in Python. Okay. So if I look at this, there's a primes variable and then it is assigned the value of this list. Okay. So if I execute this, you will see that we won't get any output, but of course, internally, it has declared and has saved a variable called primes, and that type is of type list. Okay, so we'll quickly check that once this code block is executed. We can always check the type of primes, and this time you'll see that it's a list. Okay, so you can see that it's a list type. Okay, so far so good. Let's move on. Now it's not just about integers. Obviously you can put other types of things in lists. So let's say here I've got planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, not Pluto. Okay, so there we go. That's our planets list. Now let's quickly complicate this a little further. You can have a list of lists. Okay, so let's say this is a list and then this is another list. This is one more list. I'm encapsulating this whole thing into another pair of square brackets, which essentially means this is a list of lists. Okay, so the hands variable will be a list of lists. Again, this is just a cleaner way of representing a list of lists. You can also just flatten the whole thing out by writing it in one line like so. Okay, now all of the examples that we have seen so far, this contains only integers, this contains only string, this also contains only string. Now it turns out a list need not be a homogeneous collection of variables. It can be a heterogeneous combination of variables. Okay, so let's go through that with the help of an example. So I have my favorite things variable declared here. So this is 32, and then raindrops and roses, it's a string, and then help is a function. Okay, again, help is a function. You can store functions inside a list. Okay, so there are no rules here. So I can run it, no problem whatsoever. Okay, so we've seen a fair bit on understanding lists and how to declare lists. Let's just go through how to access a list. All of these lists that we have worked on so far have been declared, ready to go. But how do we now access the list? Okay, so we're going to tackle that next. Remember the planets list: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Now, if I put a square bracket pair in front of the planets variable and then say 0, what it will do is access the first element of that list. Okay, again, it's a little thing to kind of pay attention to. Python is a zero-based indexing language. Okay, so if you say planets of 0, it will access the first element. If you say planets of 1, it will access the second element, and so on. Okay, so this will be Mercury, and then if I say planets of 1, this will be Venus. Okay, which planet is farthest from the sun. Let's say this planet's list is actually stored in the order of how distant it is from the sun, or how farther it is from the sun. Now, if I have a list which is sorted alphabetically like this, and I want to access the last element of that list, okay, then ideally, if we keep going, we'll have to say planets of 2, planets of 3, planets of 4, but where does this end, right? So you'll have to know the length of the list beforehand, which is again might not be to your knowledge. If you're working with a list and you don't know the length of that list, you know what? You just want access to the last element. How do we do it? By doing planets of -1. Okay. So what this does now is starts accessing the list in reverse order. Okay. So our order was Mercury, Venus, Earth, Mars, all the way till Neptune. So this will actually output Neptune. Okay. And then this -2 will access the second last element, which is Uranus, right? So that's how we access one particular element from a list. Now let's say I want to access a subset of the elements, not just one element, but a subset of the elements. How do I do that? Here I'll have to again write the name of the variable, specify the start element, have a colon in between, and then specify the end element. Okay. So what will this result in? Mercury, Venus, Earth. Will it output Mars? No, it won't. Okay. So what this essentially means, 0 to 3, is access the 0th element, access the first element, and then access the second element, which again implies access the first, second, and the third elements respectively. So what this does is, whatever number you put on the upper limit of this range, it will access all the numbers one less than that. Okay. So if I look at the output, you'll see that Mars was not captured here. Just the first 3 elements, the first element, second element, and the third element, which essentially in Python's zero-based indexing terminology, it's the 0th index, the first index, and the second index. Okay. Now I can choose not to write this 0, and if I don't do that, what will happen is it'll just by default take everything from the start and then all the way till the upper limit I specify here. Okay. So this will still come to Mercury, Venus, Earth. Okay. Now what if I do this? I specify the start element but do not specify the end element. What it will do this time is it will start from the third index and then go all the way till the end of this list. Okay. So what's the third index? Mercury, Venus, Earth, Mars. Okay. So the third index is actually the 4th element, right? So from there, from Mars, it will print everything all the way till the end of the list. Okay. So that's a quick one on slicing indices or slicing a list. Okay. So specify the start element, specify the end element. You don't specify the start element, it just picks up from the beginning. You don't specify the end element, it goes all the way till the end. Okay. Now let's make this a little more interesting. We've seen positive and we've seen the negative, right? So 1 colon -1. Now obviously 1 means it's the first index, that means it's the second element. Okay. So this will be, it will start from Venus, and then since we have specified -1, which is the last element of the list, remember, it does not take into account the number that is written here. It will just go 1 before that, right? So everything from the second element to the second last element will get printed here. So there'll be no Mercury, there'll be no Neptune. Everything in between will get printed. Okay. So you have Venus, Earth, Mars, Jupiter, Saturn, Uranus. Okay. Now what if I do this? it essentially means the list will go from -3 to -2 to -1, but then I haven't specified, right? So it will go all the way till the end of the list. Okay, so it will just output the last 3 planets. Again, I'm just giving you a cheat sheet sort of a thing on how to slice lists. You want to traverse it from the reverse, traverse it forwards, I don't care. This will become your cheat sheet. So whenever you're looking to traverse a list in a particular order, you can just pick the snippets off of this notebook and move on. Okay. Now, we've done declaring lists and we've done accessing a list. Let's discuss modifying a list. Okay. Now we have the planets, and the 4th element or the 3rd index of the planet, I access it and then say I want to assign the value of Malacandra to this particular element. Now if I do that, what will happen to the 4th element? Mars here gets squashed to Malacandra, right? Now Mercury, Venus, Earth, Mars, that's a lot of big names, right? So let's shorten the whole thing up. So I'm going to access the list, the first 3 elements of it, and then I'm going to say, you know what, take those first 3 elements and assign them these values that I am providing you. So it will become Mercury, Venus, Uranus. Okay, doesn't matter what the values are. I'm just talking about how to assign or modify a list. Okay, so what happens now? The first 3 elements get modified because of this, and then we print it, but then I reset it. Okay, so we're back to square one. Now let's do list functions. Now it turns out list has a bunch of convenience functions that you can access. What if you want to know the length of a list? It's done by the len function, len. So if I see the length of the list is 8, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So there are 8 elements, so the length is 8. There is a sorted function which will basically sort this list alphabetically, right? So if I run this, you'll see that Earth comes first this time. Why? Because it's sorted alphabetically now, right? And whenever there are 2 letters, two elements that start with the same letter, it just takes into account the next one. So Mars has an A in it as the second part. This has an E in it, so Mars wins. It comes first, right? And so on and so forth. Venus comes last. Okay, so this is how we can sort things alphabetically. Now for numeric lists, we can also calculate the sum. Okay, so if I take the sum of the primes, it will just do 2 plus 3 plus 5 plus 7, which is 17 in this case. Okay, we've looked at this before, the min function and the max function. This will output 7 and the min will output 2. Let's discuss a couple of more methods to modify a list. So we've seen that if I want to access the 3rd element of the list, I can do it like so. Okay, now what I want to do is take a new value and just append it to the end of the list. Okay, so whatever the list was, you just append one to the end of it. Now I've already executed this piece of code, and again, every time we see a new function, you can just call help on it. So it just says append object to the end of this list, right? So list.append will yield now this time all of the 8 planets along with Pluto as well. Okay, now of course we know Pluto is not a planet anymore, so we want to now remove the last element of a list. So what do we do then? We do call the pop function. So we do planets.pop, and once this gets executed, it outputs the value that it popped out of the list. So if we see planets again, no more Pluto. Okay. Now let's discuss searching a list. Now, I have this list, or the planets list, and I want to search a particular planet, and I want to know which index it is at. Okay. So what I can do is take the list's name and then do a dot index and then search for what I want to search. Okay. So this yields an output of 2. That means the third element of this list is actually Earth. Let's quickly confirm that. So we know the third element of this list is Earth, and there we go. Right? So you can do the reverse as well. Search for a particular string. Okay. Now, in which index does Pluto occur? Wait a minute. We had appended Pluto as part of the list, but we had popped it out. We had removed it. Right? So what does this give you? Value error. Pluto is not in list. Okay. So you see, in our quest for finding elements in the list, we encountered this nasty error with all the red stuff. To make it more graceful, the search, what we can do is just do this: Earth in planets. Now this will evaluate to true or false. True means Earth exists in the list called planets. False means Earth does not exist in the list. So obviously this will evaluate to true. Okay. So again, both of them are trying to achieve the same thing. It's just that the output of this is way more graceful, understandable, readable compared to this. Okay. Now, is this string present in the planets list? No. So this will evaluate to false. Okay. Now you can always call help on a particular list to go through all the functions that are available to you, right? So that's a long list of functions that are available to you. Okay. So that's that. Let us discuss tuples now. Tuples are almost exactly the same as lists, except for a couple of things. You cannot modify tuples once you've declared them. Okay. So let's say the way to declare a tuple will be all of the exact same things you did with the list, but instead of using square brackets, you just use parentheses. Okay. So 1, 2, 3, that's going to be the value of t. And you can choose not to specify the brackets as well. Again, this is called tuple unpacking. It automatically takes that into account. Okay. Now, let's quickly check the type of this variable. And it says it's a tuple. Great. And what we had said before was you can't modify tuples, right? So if I want to grab the first element of this tuple and reassign it the value of 100, I'll get an error. Okay. Type error. Tuple object does not support item assignment. So you cannot reassign tuples. Okay. Where is this useful? This is useful when you don't want to accidentally modify a stuff that you know cannot change during the entire life cycle of a program. Okay. And due to this immutable property that they cannot change, they are slightly faster than lists. So for all the tech savvy people out there, there's a concept called hashing, and it's a hash data type. That's why it's very accessible. It's accessible way faster compared to a list. Okay. So again, if you don't know what I'm talking about, there's no worry. Still conceptually you're covered. Okay. Now, tuples are often used for functions that have multiple return values. Okay. So for example, the as integer ratio method of float objects returns a numerator and a denominator in the form of a tuple. Okay. So let's say I have this variable called x with a value of 0.125, and now I can access a property of this particular float that tells me as integer ratio, so give me a numerator and a denominator instead of giving me the decimal output, and this will return a tuple of 1 and 8, right? Now, these multiple return values can be individually assigned as follows. Again, this is called tuple unpacking. So if I take x dot as integer ratio, it will return me 1 comma 8. Now I can assign that not only to a tuple but to two different variables, because I know it's going to give me two outputs. Okay, so I assign the numerator variable and the denominator variable, comma separated, the output of this. So what will happen is this value 1 will get latched on to this variable, and then that value 8 will get latched on to this variable. Okay, and then again, if I print numerator divided by denominator, I'll get back x, which is in this case 0.125. Okay, last thing, we have some insight into the classic stupid Python trick for swapping two variables. It's almost a meme in itself. If you're again familiar with a programming language like C, swapping variables is a bit of an untidy business where you'll have to declare a temp variable and then do the swapping, right? So because of these of the niceties of tuple unpacking properties, we can do this in one line. Okay, so let's say we want to swap two variables, a equals 1 and b equals 0. That swapping means b will become 1 and a will become 0. Okay, so how do I do that? A comma b equals b comma a. That's it. So the value of b gets latched onto a, the value of a gets latched onto b. Okay, so once that will happen, if I print a and b, I should be able to see 0 and 1 instead of 1 and 0, the exact reverse, right? So I can see 0 and 1. So that's an exhaustive understanding of array data structures in Python with lists and tuples. I hope you enjoyed this video. Thank you very much.